All right, we're going to talk about area and perimeter and the area of similar figures. Area is the number of square units in the interior of an object. So for example, for this figure can be broken down into square units. That means 1 unit by 1 unit that creates a square. So if I count up the number of little square units in here, that would tell me the area of this figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So the area is 36 units squared. Now, there are quicker, easier ways than counting, which is very helpful when the area gets to larger numbers. It's already pretty annoying right there. The length of this side is 1, 2, 3, 4 units. And the length of this side is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And this whole shape is a rectangle. And one of the ways we find the area of a rectangle is length times width. So we do 9 times 4, which is 36. So when we do all of these area formulas below, these are formulas that are made to find the number of square units. So it's a way of doing things a little faster than counting. So here are all the formulas for the shapes that we're going to be dealing with. The formula for area of a parallelogram is base times height. For a rectangle, these are really the exact same thing, but sometimes instead of base times height, we call it length times width, but it's the same thing. For a rhombus is 1/2 times diagonal 1 times diagonal 2. So you're multiplying your diagonals and multiplying by 1/2. Now, a rhombus is a type of parallelogram, so base times height would work also if you have that information. A square, it has its unique formula, side squared. You can take the length of one side and square it. That'll give you the area of a square. But remember, a square is a rhombus, rectangle, and parallelogram. It's a subcategory of all of those. So any of those other formulas that you have, if you have that information, you can use those as well. So any of these formulas would work for the area of a square. So depending on the information you have available, you would choose which formula you could actually use. For a triangle, area is 1/2 times the base times the height. And for a trapezoid, it's 1/2 times the sum of the bases times the height. And one very, very, very important thing when we're doing this is that base and height are always perpendicular. You're always looking for that right angle, because if you find that right angle, then you'll find where the base and height are. Alright, perimeter is the distance around an object. That's just the sum of the measures of the sides. There are some formulas out there for certain shapes, but you really don't need any. You just add up all the sides and you're good. That'll give you the perimeter. So let's try some of these problems. So the first step in all of these is to identify what shape you're looking at. So right here, the opposite sides are congruent, but I do not know that I have right angles here, and so I know that this is a parallelogram. So for a parallelogram, I need the base and height. Remember, area is base times height. So remember, base and height are always perpendicular, so I'm looking for that right angle. Right here I see the right angle. This will be the base, 10 centimeters, and the height is perpendicular to that, so the height is 4 centimeters. The 8 cannot be the height because the 8 is not perpendicular to the base. It's not forming a right angle with that 10 centimeters. So for area, I'm just multiplying the base of 10 times the height of 4. When I multiply those, I get 40. And area is always units squared, so that would be centimeters squared. For perimeter, we just add up all the sides. So for perimeter, I am adding 10 plus 8 plus 10 plus 8. I'm just adding up all of those sides. I am not including the 4 because that is not one of the sides of the figure. That's the height going through the interior of the figure, so that is not included. So 10 plus 8 is 18, plus 10 more is 28, plus 8 more is 36. And perimeter is a one-dimensional measurement, so it is just regular centimeters. Alright, on number 3, you should notice that all of the sides are 5, meaning all the sides are congruent. And so therefore I know this is going to be a rhombus. I don't have right angles, so it's not a square. The diagonals are not congruent, so I know it's not a square, but it is a rhombus. So for a rhombus, I can use the formula 1/2 times diagonal 1 times diagonal 2. So I just need to know the lengths of the diagonals, and I'll substitute those in. Well, the length of this diagonal is 3 plus 3, so that entire diagonal is 6. And the length of this diagonal is 4 plus 4, so the length of that entire diagonal is 8. So now that I know the lengths of the diagonals, all I got to do is plug them into the formula. So 1/2 times 6 is 3, and 3 times 8 is 24. So the area is 24, and they did not give us units here, so we'll just write the word units squared. Area is always units squared. It's a two-dimensional measurement. Okay, the side lengths are all 5. And so for perimeter, we're just adding up all the sides, or in this case, all the sides are exactly the same. So you could either do 5 plus 5 plus 5 plus 5, or you could do 4 times 5. Essentially the same thing. Either way, should come out to 20 for the perimeter. And perimeter is just regular units. One dimension. Okay, on example 4, we can recognize, hopefully, that this is a trapezoid. Notice the arrows here labeling that these are parallel, so I got one pair of parallel sides. The other pair of opposite sides are not parallel, so this is a trapezoid. Remember, the formula for area of a trapezoid is 1/2 times the sum of the bases times the height. Well, the bases in a trapezoid are always the sides that are parallel to each other. So the 8 and 12 are both parallel to each other. It does not matter which one is considered base 1 and which one is considered base 2. And then remember, height is always perpendicular to the base. You'll notice that this 7 is forming a right angle with the side length that's a 12. So here the height is perpendicular to the base, 7 being the height. So once I've identified all those parts, all I got to do is plug them into the formula. So the bases are 8 and 12, so I substitute those in. The height is 7, substitute that in. And we just find out what we're working with here. 8 plus 12 is 20. 1/2 times 20 is 10. And 10 times 7 is 70. So we got an area of 70. Again, they did not give us particular units, so we'll just say units squared. And sometimes when we do unit squared, we just write the U to shorten it up a little bit. Alright, let's look at example 5. Notice right here it says assume all angles are right angles. So this figure as a whole is not one of the shapes we learned. This would be a composite figure. I can break it up into a couple of shapes that we do know how to find the area of. If I draw a line right through here, I can split this into 2 separate rectangles, and I can just find the area of each one of those rectangles individually and then add them together for the total area of this figure. So if I'm looking at this rectangle right here, remember, for area it's length times width. So 6 times 6, this would have an area of 36. And then for this rectangle, it's got a length of 4. And then what is the width? I would have to add 5 plus 6, because if this is 6, this is 6. Opposite sides of a rectangle are congruent. 5 plus 6 plus 5. And when I do that, 5 plus 6 is 11, plus 5 more is 16. So for this rectangle, the length and width are 4 and 16. So 4 times 16 is 64. So I found the area of this rectangle was 36. The area of this rectangle is 64. If I add those together, we get an area of 100 units squared. Area, again, 2 dimensions, always units squared. Now for perimeter, we need to add up all the sides. So I'm going to start here. So I'm just going to mark that so I remember where I started at. And add up all the sides. 4 plus 5 plus 6 plus 6 plus 6 plus 5 plus 4, and then this side over here was 16. So there's all the sides I need to add together to get that answer. So I'm going to use the calculator for that. 4 plus 5 plus 6 plus 6 plus 6 plus 5 plus 4 plus 16. And when you add all those up, you should get 52. And again, perimeter is one dimension, so it'll just be regular units, 52 units. Alright, so we've done some straightforward area problems. Let's talk about what happens if you change some of the dimensions. If all the dimensions of a figure are multiplied by the same number, that means they're going to be changed proportionally, then the new figure will be similar to the original figure. Remember that corresponding sides of similar figures are proportional. So, let's start by just finding the area of this triangle. Remember, the formula for area of a triangle is 1/2 times base times height. And something missing from the picture here, you need a right angle here so that we can actually do this problem. I'll have to fix that on the copy. The base and height here are going to be 4 and 6. We know that because they're perpendicular, which is why that right angle is important. So we'll say the base and height are 4 and 6. It really doesn't matter which one's which. 1/2 times 4 is 2. 2 times 6 is 12. So I know the area of this triangle is 12 centimeters squared. Alright, let's find out what happens as we change the dimensions. So the original area is 12 centimeters squared. Let's change the base and make it twice as long. And let's change the height and make it twice as long. So they're both being multiplied by the same thing. So the original base was 6 centimeters. So if I make that twice as long, that would make the base 12. And the original height was 4 centimeters, so if I make that twice as long, that would make the height would make the height 8. Let's try the same formula again with these new numbers. So if I do 1/2 times base times height, that's 1/2 times 12 times 8. And half of 12 is 6. 6 times 8 is 48. So the new area would be 48 centimeters squared. Let's see how that compares to the original area. Let's take the new area and divide it by the original area. So that's 48 divided by 12. And when we do 48 divided by 12, you should get 4. Because the new area is 4 times as large as the original area. Okay, let's try this again. And this time let's make the base and height both 3 times as long. So again, the original area is 12 centimeters squared. The original base was 6. The original height was 4. So if I make the base 3 times as long, that's 6 times 3 is 18. And then I make the height 3 times as long. 4 times 3 is 12. Let's find the area using those new numbers. So again, 1/2 times base times height. So half of 18 is 9, and 9 times 12 should be 108. Alright, so now let's compare the new area with the old area. So I'm going to take the new area, divide it by the old area, and see how that compares. 108 divided by 12 is 9. So the area is 9 times larger. So hopefully we can start looking for a pattern here. When we made the base and height both twice as long, the area became 4 times bigger. When we made the base and height both 3 times larger, that made the area 9 times larger. 2 times 2 is 4. 3 times 3 is 9. Now, because these changes are exactly the same, as long as we're focusing on similar figures, when you take a number and multiply it times itself, you're squaring it. So 2 squared is 4, 3 squared is 9. So we can start shortcutting this process a little bit if we want to. So let's look at the next one. This time we're going to make the base half as long and the height half as long. Well, the original base was 6, so if we made it half as long, that would be 3. If we make the height half as long, half of 4 would be 2. So we could do the same process we've been doing and plug these numbers in the formula and find out what we get. Or, what's 1/2 times 1/2, or 1/2 squared? 1/2 squared, 1/2 squared is 1/4. 1 squared is 1, 2 squared is 4. So because the dimensions have been halved, the area is actually going to end up being only 1/4 the size of the original area. And we can find that out if we plug these into the formula again. 1/2 times base times height. So if we do 1/2 times 3 times 2, you should end up with an answer of 3. So the new area is 3 centimeters squared. If I take the new area and divide by the old area or original area, 3 over 12 reduces to 1/4. Just like what we got when we did the 1/2 squared. 1/4. We knew it was going to be 1/4 the original size. So what conjecture can we make regarding the areas of similar figures? Okay, you can square the change in dimension which could also be called the scale factor. You can square the change in dimension to find the change in the area. Alright, so with that new information, let's try example 7. It says the area of a square is 49 feet squared. Find the area of a square with sides 4 times as large. Okay, well if I know that the sides are all going to be multiplied by 4, and I want to know how that affects the area, remember I can take whatever the dimensions are being multiplied by, and I can square that number to find out what the change in the area is going to be. So 4 squared is 16. So I know that the area is going to be 16 times larger. So I will take the original area, 49, and multiply by 16. So 49 times 16 is 784. So if the original square had an area of 49 feet squared, and I know the sides are going to be 4 times larger, then I know that new square is going to have an area of 484 feet squared.